Hi 3Ms, I've decided to do a review trig video, so watch if you wish. I've got handouts to go with it. Sorry. Because it's a crazy week and we had our snow day yesterday. So I thought the first thing I would start with was the discussion of which formula should I use, because I've not got great concern that you can use your calculator well, but it's choosing well. So of the 5 triangles we have in front of us, the first one, our most efficient way to solve that thing would be to use SOHCAHTOA. The second one does not have a right angle in it, so we cannot assume that we can use SOHCAHTOA or Pythagorean theorem. And my thought process is, can I use sine law? That's the best second choice. And I need to have an angle side pair, like I've drawn on the board here, complete, so that in my sine law ratio, I have one of the fractions completely done. I don't in this case. I don't have an angle. Oh, I lied to you. Lied to you right there. So I modeled my thought process. I do have an angle side pair across from each other complete, so that would be best choice for the sine law. The third one, I do not have a right angle triangle, so I could not use SOHCAHTOA or Pythagorean theorem. So I'm going to look for an angle side pair complete. For this one, my angle is a question mark across from the x. I don't have any angle side pairs complete. So I would be stuck with the cos law. Fourth one, I have side angle side. I do not have an angle side pair complete, so I am going to use the cos law. So for the few of you that have really remarkable memories, if you have side angle side, like we have in this order, a side, the angle between them, and a side, it will be the cos law, because you haven't got a side pair complete. The cos law for the middle one is because we have 3 sides and no angles at all, we would have to use the cos law. That second one is because I have a pair. Okay, last one. It is not a right angle triangle. I can't use SOHCAHTOA or Pythagorean theorem. I am looking to see if I have an angle side pair complete, and I do. I have a side across from an angle. The sine law would be my best choice. Yay. Whoops. Don't worry about that crazy puzzle. Okay, for 7.4.3, which you have on your handouts, our first job is to look at these triangles and decide what we would use. For this first triangle in the upper left, I am looking to see if I could use SOHCAHTOA or Pythagorean theorem, and I can't. So my second choice would be sine law, and I'm looking to see if I have an angle side pair complete. I have the 30 across from the 35. So yay, I can use sine law. Triangle on the top right. I have a right angle triangle. That means I could use Pythagorean theorem or SOHCAHTOA. For this one, I don't have any angles. I have 2 out of 3 sides, so Pythagorean theorem would be my best choice. Just remember, if you're going to use Pythagorean theorem on this one, you would have the 124 as your longest side. It would stand alone. So we would set it up as 74 squared plus p squared. So the 2 smallest sides is 124 squared. Okay, the third one. We have triangle DEF. It has 3 sides and we're looking for an angle. So my thought process is, can I use SOHCAHTOA or Pythagorean theorem? So that's always my first. My second thing to think about is, can I use sine law? And for sine law, I need to have an angle and side pair complete. You're welcome to go and write that on the anchor chart if you want. I don't have any angles at all, so I can't use the sine law. So for this one, I am stuck with the cos law. Fourth one, I have a right angle triangle, so I've got Pythagorean theorem or SOHCAHTOA. For this one, I only have one side, so I can't use Pythagorean theorem. I'm going to be using SOHCAHTOA. Let's take a second and choose which ratio would be appropriate. So my 29 degrees is the angle that I'm given. So I'm going to mark the sides, adjacent, opposite, and hypotenuse. The hypotenuse side is U. It's across from the right angle. My opposite is way over here, and my adjacent is the one right beside. So now that I've got it marked, don't care at all about the adjacent side. The only trig ratio that doesn't use the adjacent side is sine. So not the sine law, but the sine ratio. Let's just set it up and we'll solve it in a minute. Sine of 29 degrees equals opposite over hypotenuse 14.3 over u, just to make sure we didn't get the wrong law there. Okay, number 5. We're going to solve a few of these in full in a minute. I have side, angle, side in a row. And if you remember, that means we use the cos law. But if you don't, my thought process would be not a right angle triangle. Can I use sine law? Do I have an angle side pair complete? I do not. The only angle I have is that one, and I don't have the measure of y, so I can't use sine law. Cos law it is. If I want to find measure h in this triangle GHJ, and I have 3 angles, I can't actually solve, because I would need to have one length to be able to compare lengths of this thing. I could have a big triangle that has 68 degrees, 73, and 39, or I could have a teensy-weensy triangle that has 68 degrees, 73 degrees, and 39, and I can't solve it if we don't have one length to anchor it. Bottom left. I have 2 angles and a missing angle. Can I solve it? Yep. Don't forget, triangles add to 180 degrees. That can be super helpful. Last one. I have an angle and 2 sides, and I'm looking to solve for another angle. So my thought process would be, can I use SOHCAHTOA or Pythagorean theorem? No, I can't use SOHCAHTOA or Pythagorean theorem, no right angle. Then I think about whether I can use sine law, and I can, because I've got an angle side pair, so that when I set up the sine law, I have one of my fractions complete for that ratio. So I am going to use sine law for this one. So I have copied a few of these again on the next few pages, and we're going to do the work to solve them. The first one, I have 3 sides, and I'm looking for an angle. We decided that we would use the cos law. I don't have any angle side pair, and it's not a right angle triangle. So I'm going to set up the cos law as usual, and I know that the cos law ends with an angle, so that's where I want my theta to be, at the end of the cos law. I have to start my cos law with the opposite side to that angle. So I've got to set it up as 24 squared equals 20 squared plus 35 squared. So that looks like the Pythagorean theorem, but we subtract 2 times one of each of these, 20 and 35. So the formula is up on your anchor chart, cos theta. Okay. We want to get theta by itself. So what I'm going to do first of all is get rid of these 2 guys. So my next line is going to be 24 squared, subtract the 20 squared, and subtract the 35 squared. I am just trying to get theta by itself. And I don't like rounding and putting answers down on paper. I'd rather type it all in one shot. So what I see now is kind of ugly on the left side equals a bunch of numbers times cos theta. So to get rid of multiplication, we divide. So my next line would be 24 squared, subtract 20 squared, subtract 35 squared, over, and I put it in brackets just because some calculators are kind of funny, equals cos theta. I have written the formula in that form for you on the bottom of your anchor chart. If you're looking to solve for an angle, you're going to have some subtraction, and you're going to have division by that negative 2ab on the bottom. If you want angle theta, the last thing I need to do before I touch my calculator is get rid of the cos word. The opposite function of cos is inverse cos, so we use second function cos of big ugly bracket. And you need to make friends with your calculators. So I'm going to just write this down before I type it in. And I'm going to ask you to find the answer on your calculator as well and make sure that you're friends with your, and make sure it's in degree mode. Let me just write that down. Pause it for a second and make sure you get the same answer. 41.5 degrees. The second triangle that we're going to look at today is a side angle side. And we decided when we were choosing the right formula to use that we could not use SOHCAHTOA or Pythagorean theorem, nor could we use the sine law. So we have the cos law again. This time, however, we're looking to solve for a side. So my cos law, subtract 2ab. Okay, on the formula sheet, we got to put the right numbers in the right spot. If I have an angle of 83 degrees, that goes at the end of the equation, and so I have to start my equation with the opposite side. So I'm going to set it up as y squared equals the other two sides squared, 25 squared plus 30 squared. Subtract 2 times one of each of those, 25 and 30, cos the angle 83. I just need to type that into my calculator very carefully. Try it on yours as well, please. 1342.2. To find y itself, sorry, that's an approximation, I'm going to do the square root. So I'm just going to leave my answer in my calculator and take the square root of it. And I have an answer of 36.6. The last thing I do is just check that that's a reasonable answer. It is. It would be the longest side, and the other numbers are proximate to 36, so that is reasonable. For this triangle, we decided we couldn't use SOHCAHTOA or Pythagorean theorem. We did, however, have an angle side pair complete, so I can use the sine law. So let's set up the sine law using the letters A, B, and C. Sine A over A equals sine B over B, sine C over C. Okay, putting the right numbers where they belong. Sine A over little a, which would be there, equals sine 62 over little b, equals sine 35 over 30. We don't know or care about angle A or side A, but I always set up my three-way ratio anyways, just to make sure I've got the right numbers in the right spot. So we are going to solve this ratio, and the problem that I'm seeing is that I have a variable on the bottom, which can make things a little bit tricky. So we're going to multiply by b and by 30 at the same time, which some of you call cross-multiplying. So we're going to write my next line as multiply both sides by 30. Here, let's get rid of that for a second. Will be 30 times sine 62. At the same time, I'm going to multiply both sides by b. b times sine 35. So we have gotten rid of both denominators by cross-multiplying. I want to get b by itself. To get rid of b times sine 35, I'm going to divide both sides by sine 35. I haven't touched a calculator yet. It just is more accurate. Sine 35. And that I need to type in and get an answer for b. Please try it on your calculator as well. B is 46.2. Lastly, I checked that that answer makes sense. I have a length of 30 across from a 35-degree angle. I should have a longer side across from the 62 degrees, and I do, and it is proximate to the number 30. If I had an answer of 462, it wouldn't make sense, but this one really does. Last one we'd kind of started, but we have a right angle triangle, and we recognize that we couldn't use Pythagorean theorem because we only had one length. So we're going to use SOHCAHTOA. That hint also that we have an angle, so SOHCAHTOA is the tool to use. We labeled the sides at that time and said if 29 degrees is my angle, then that is opposite. The hypotenuse is u because it's across from the 90 degrees. The adjacent is right beside the 29 degrees, and nobody cares about him whatsoever. So because my adjacent I don't want or have, I'm going to use the trig ratio that uses opposite and hypotenuse. So we set up a sine ratio, and it's always sine of the angle equals what over what. And with sine, it would be opposite over hypotenuse. So for this triangle, my opposite side is 14.3, and my hypotenuse is u. So we'd already set that up, but now we're going to solve it. Like in a previous example, I have the variable on the bottom, which can be a little bit tricky. To get rid of divide by u, I'm going to multiply both sides by u. That will get rid of him on this side, but it will have me multiplying by u on this side. But at least I don't have a fraction anymore. My next line will be to get rid of that times sine 29, and I will be left with just u. Dividing by sine 29 will leave me with 14.3 divide by sine 29, and I will type that into my calculator. Please try it as well. An answer of 29.5. Okay, for today and tomorrow, you've got lots of questions to practice. Don't forget Pythagorean theorem and SOHCAHTOA. Don't forget to take a moment and use your thought process as to which equation you're going to use. And don't forget to have your calculator in degree mode.